Hi everyone, in today's video we will be looking at a sliding window algorithm, and the problem which we will be looking at is subarray sum problem. So in the last video we saw how we can find a maximum subarray using a maximum sub array using Cadena algorithm. So this time we are given a value k and we have to find a subarray of that size. So this size is given to us. And in the last one we have seen that there was no bound on this size of that subarray and we could find subarray of any size. So this time we are given a case, so let us take an example. It will be more clear by that. So let us take an array of 10, 20, 30, 40 and 50, and if k is given to us as equal to 3, so we have to find a subarray of size 3 which has maximum sum. So we'll start first with these three elements, then these three elements, and then these three elements. So this last one has the maximum size, so which is 120. So we'll return this. We have to return this value. So today we will be looking at how we can solve this problem using sliding window protocol. So let's start. Let's talk about the approach, that how we can approach this problem. So we are given this array 10, 20, 30, 40 and 50. Now one approach can be, we can start on the first element, we can initialize I is equal to 0 and we can move up till k. Okay, so like k was 3 and we can keep a sum. So initially we take a value of 0 of sum, so we will initialize it by 0, and now we can find this sum of k elements. So sum plus equal to ARR of I, and then we can, after this for loop, we can check if answer is equal to either maximum of answer or sum. Okay, so this is what we can do. Let me write this naive approach first. So we can write it by for I equal to 0 to n, where n is the size of array, and inside this we have to run another for loop for I equal to, for j equal to I to k. K is size of subarray, size of subarray. Okay, and what we will do here is, between these lines we will initialize sum as 0 sorry, and I'll do sum plus equal to ARR of I, and after this for loop I'll write this answer is equal to either maximum of sum or answer, and answer I'll initialize as 0. So using this method I will find the maximum subarray sum, which will take order nk time, and in worst case where k is equal to n, I'll get a time complexity of order n square, so which is not that good. Suppose if I want to reduce it to linear time complexity to order of n, let's do that. So for that we will use sliding window algorithm. So sliding window approach. Let's see how this sliding window approach works. So let me write the array 10, 20, 30, 40 and 50. So rather than traversing onto this, like first traversing on this then on this, we can save time because we know we have some of these two elements while we are traversing these three elements, so we can save time in that. So what I will do is I will make a sum window, so, or window sum, let's say window sum, and one I will make as best sum. So best sum is our answer which we will return at last, and window sum is some of those k elements in that window, k elements. So let's start. So first we will calculate a sum from I equal to 0 to k inside the array. So let's say that sum is window sum. So first we will calculate this, which will be plus equal to ARR of I. So now we have some of these first k elements. So in 10, 20, 30, 40 and 50, and k is equal to 3. Now we have sum of these three elements. So window sum, which I am writing in short w underscore s, will be 60, and best sum, I'll initialize it with 0. Now we will start traversing from I equal to k to n, and in each step what I will do is I will make window sum as ARR I, and then I'll subtract from this ARR I minus k. So let's see what this line does. So initially I have 60 inside my window sum, and right now I am on this position. So my I is on this position, which is 3. So this is 0, this is 1, this is 2, and 3 and 4. So inside this, let me rewrite it here: 10, 20, 30, 40, and 50. So I have sum of this. Now I want to slide this window like this. Okay, so for sliding, what I have to do is I have to subtract this element and add this element. So for subtracting this element, I'll write I minus k. So for now our I is equal to k, so we will get here 0. So we have subtracted this element, and this thing ARR I, it is adding that element, so it is adding this 40. Now we have a window sum of this. So 60 plus 40 minus 10, which will be 90, and sum of this window, this one, is also 90. And now I'll make sure that my answer is maximum of either answer or my window sum. So like we did for 10, 20, 30, 40, and 50. Now we have sum of this as 90. Now we will slide this window again till here, and we will remove this element and add this element. So removing this element will give me, we will have 90 plus 50 minus 20, which is equal to 120. And then we will check if answer is maximum of either 90 or 120. So which is 120, and we will return 120 as our answer. So this was the very basic question of sliding window protocol, and in future we will be looking at some more complex problems on this. And if this video helped you, please hit the like button and subscribe to the channel. Thank you.